Welcome to lecture 52, and in this lecture we are going to start building what we mentioned in the first phase of what we mentioned in the last lecture, which is that we are going to take our 17 2D plane groups and start to add T3 and build them into 14 3D space lattices. And so in doing so, we're going to start off with adding T3s to the simplest case, which is the Triclinic Lattice. So, we get the Triclinic from the simplest case, which is the P1. So P1 is fairly simple. We have, let's call our vector here T2. We'll create T1. So our lattice is basically looking like this. Now when you think about adding T3, because there's no other symmetry elements, it can go anywhere. And so pretty simply, it can just kind of come out here, just drawing this generically, and stop anywhere. And this defines then a lattice because there's no other constraint. So T3 is completely general. So you end up with here, the magnitudes are not required to be equal to each other at all. Right? Everything can be completely general. And the angles keep on doing that. Are not only not equal, but no specific value. So they're not equal to each other, and they can be whatever angle you want. Now, just to prepare you for what is coming, one of the rules here is that T3 cannot destroy any symmetry in the plane group. And so you can imagine if I have a symmetry element, let's say that this has some sort of a twofold axis, right? Then T3 can only go up, and it has to land somewhere in space where it has another twofold axis that'll allow this whole unit cell and crystal structure to be reproduced. If I land into random space, I change by definition the lattice, right? The two-dimensional lattice, because I'm all of a sudden generating in this random place a new symmetry element. Here I don't have to worry about the triclinic case because P1 has no symmetry elements. But what it means is that my T3 in higher symmetries is extremely limited because there's always the case where I can go straight up because I'm just reproducing this same element right above it, and that's going to be okay. But in a way, I'm kind of creating my own symmetry there because I am actually forcing these two angles to be 90 degrees when I do that, right? So the symmetry and how many other of these symmetry elements are in there extremely limit my ability to pick T3s. And there's going to be so many choices, that's how come I can generate our lattices so quickly. But the first one has been done, which is the triclinic system, has no other symmetry elements here. Now, what triclinic will be compatible with is one other symmetry element, or can be compatible with one other symmetry element, which is inversion. But that in itself is the three-dimensional one. So from a plane group, we don't have that in here. But we can add that later, and that adds a little bit of complexity to the triclinic. But besides that, this is how we arrive at the triclinic. All we do is take P1, add a generic T3, and we have it.